Hi, I'm Randy Templeton, and I'm the architect of the LF Edge implementation, Linux Foundation Edge implementation of the FDO spec. And I'll be running a demo of of FDO using the LF Edge implementation. And you can see here, if you're interested in the LF Edge implementation of the FDO spec, you can go to lfedge.org. And currently, the project that the implementation is under is called Secure Device Onboard. We do have a notice here, though, that name will be changing to FDO Device Onboard in February of 2023. So a little over a month, it'll be referred to as FDO Device Onboard instead of Secure Device Onboard. But this is the LF Edge implementation is an open source implementation. It comes with an Apache 2.0 license, and so you can use this implementation to integrate into your products and solutions. We have like other LF Edge projects. There are other LF Edge projects like Open Horizons, which is done by IBM, which does incorporate FDO onboarding into their project. And so once you go to the LF Edge implementation, you can see on GitHub, this is where our implementation would be found with the license. And so we have various projects here. You can see what I'll be demoing is the PRI FDO IoT. You see here we have client SDK FDO IoT. PRI FDO IoT is basically our Java-based reference implementation of the FDO device server end of the FDO device onboarding specification. In this demo too, I will actually be using a client-side implementation as well in Java. Typically, for like production Intel devices, you would use our C-based implementation of an FDO device in conjunction with the server side. Either because of the specification, you could be using our implementation, the LF Edge implementation, or any other implementation. You can mix and match these as long as they're conformant. Another thing that I'll note when I run this demo, you'll see me typing commands in and everything to initiate things. In real practice with FDO, FDO is designed to be automatable and everything happens automatically. For the sake of the demo, though, so I can control when things happen and explain when things happen, I'll be initiating some things manually, but that's not what would, like I said, the implementation of FDO is automatable, but it's also zero touch. So in real life, you wouldn't, no user interaction would be required, right? But I'm doing this interaction simply for educational purposes and to show things in the demo. So to get started with the demo, if you go to the LF Edge website and our GitHub repository, we have various servers that you can use that implement all the entities defined in the specification. So there's a rendezvous server, there's a owner server, there's a reseller server, there's a manufacturing server for manufacturing devices. So all that's found on the LF Edge code, and I'll just be walking through the overall process here. And so the purpose of this demo, we're just going to simulate doing a. And why is this? Right there. Just curious why there's. Looks like. So for the purpose of this demo, we're just going to be downloading a package, an onboarding package to the device, and we'll just show how that occurs. I'll start out with a device that hasn't been going to start with the manufacturing process. And if I go here, let me hang on. I'm going to download payload, a file called payload. And so in this our device directory, that file does not exist, and I don't have a device credential, an FDO device credential. So I'm going to start with the manufacturing step, and that's going to give me a device credential. So during manufacturing here, we're basically providing FDO credentials here, and we don't know though who's going to provide the onboarding payload. And we don't know what the payload is. That will be determined later by the TO2 protocol. The only thing we're going to know during the manufacturing stage is where the rendezvous server is. That we'll know. Then using the TO1 protocol, the device will figure out who's going to provide the onboarding package and when that gets downloaded. So the first step I'll do here is I'm just going to run the device here. And again, in a normal device, in the real world, you just power on the device, and this would happen on it. So you can see here that when the device ran, it ran what we call the DI protocol. This is defined in the spec. It's a non-normative protocol. Is described in the spec for as a protocol you can use for manufacturing. And so you can see here these messages were being sent. A GUID was created and placed in an ownership voucher that identifies this device. And so if we go over to the specification, you can see that for DI, you can see these same message numbers. This is the DI protocol. There's basically two messages. For here, the even numbers are outgoing from the device to the owner, and then the odd numbers here are basically the reply. So two messages, but a request and a reply for each, for a total of 4. If we switch over to the device, you can see the same corresponding messages. The FIDO spec also uses CBOR specification for describing all these. So these are the CBOR messages. So you can cut and paste. I can cut and paste all that information here into like a online tool here, like CBOR Me, and it'll decode it for me. So this is all how you can see that we're implementing the specification here in the messages in the specification. So now, now that I've done this manufacturing in my application data directory, you can see I have this new credentials.bin. That's my new credentials. So when I ran the device and it didn't exist, it triggered the device to go into manufacturing mode to get that credential. Now that we have that credential, we can run the device again, and now that it has the credential, it'll read that credential and find out what it needs to do next. And the next thing it'll need to do is do TO1 to get the owner that is going to provide our payload.bin, and it's going to find out where that owner is. So I'm going to run the device again, and now you can see here. If we scroll up to the beginning, it reached out to the rendezvous server. That's what we call the TO1 protocol, and it found out where that rendezvous server was, and found out where the owner is. And so we can see here TO21 complete owner is at, and it found out where this owner is, and then it initiated TO2 protocol, which this is communication between the owner and the device, and this is where all the security happens, where basically we authenticate the device and we authenticate the owner. The ownership voucher is exchanged between the two. All the elements of the owner voucher are verified. Signatures are verified, and an encrypted tunnel is established. Basically, once you get to message 65, everything after that is encrypted between that owner and the device. A private encrypted channel is established. So all the messages beyond that, you can see the payload is always binary because of CBOR, but even if you coded this in CBOR, the content of those are encrypted. And so we have this trusted channel. And so what we can do is use that entrusted channel to deliver credentials, right? Certificates, passwords, any credentials that we need for this device to securely connect to a DMS. And so all that's taken care of by the TO2 protocol. And then you can see here, we part of the protocol, we fetched this payload.bin from the owner and downloaded it onto the device. So if I go, now if I go into my data directory, there's a new file there, payload.bin. That's a okay file that we downloaded. Again, that could be a certificate, that could be anything for the onboarding of the device. And so if we, that's on the device side. If we flip over to the owner side, we can see here the server side was processing all these commands and again verifying signatures and providing all the information to download the credential. And so with this, by running this FDO process, we were able to take a device that didn't know where its onboarding package was going to come from. It didn't have that access to that during manufacturing. During manufacturing, the only thing that it had access to was a rendezvous server address where it could go ahead and figure all this stuff out after manufacturing. And that's what we call late binding, is that we're binding all this information after manufacturing instead of during manufacturing. And so that's the demo. Is there any questions people have regarding the demo?
Randy, thank you so much for that. If anyone has any questions on the demo, just let us know in the question widget. We'll just give it 1 sec here. Nope, I think we're good.
Okay, thanks.
Hey, thank you so much.
Okay.
All right, folks, just give us 1 moment and we will we'll move to Paul Heim, who will be presenting on our upcoming certification programs.